So let's go back to plants because that's what we're mainly interested in. If we analyze these different types of memories in plant processes, encoding, storage, and retrieval. So I want to start with short-term memory. Can we define short-term memory in plants? And our example here is the Venus flytrap, which we learned about in a previous lecture. So let's review again this movie, which we've already seen, which shows how the Venus flytrap waits until its prey has gotten into the middle and then closes on it. Okay, just a quick review to remind you what we learned earlier. What we saw was that the prey has to touch two hairs. It'll touch a first hair, and then if within 20 seconds a second hair is touched, the trap will close. If it was more than 20 seconds, the trap has forgotten this information and remains open. So at a very basic level, this is a clear example of short-term memory, a memory that lasts a number of seconds and then is forgotten. So what is the mechanism by which the Venus flytrap encodes this short-term memory? Well, the simple answer is in the electric charge that we learned about in understanding the mechanism of the cloning. And interestingly, this electric charge, the electric information, is similar to the workings of our brain. Again, to review, what do we have? In the first touch, we get a depolarization, a change in the electric charge across the membranes, and a release of the calcium ions. And again, I remind you that the release of calcium ions in response to the depolarization is very similar to what happens in neural communication in humans. When you get the second touch, you're getting a second depolarization and a release of more calcium ions. And here's where we come into the memory. If the accumulative charge, the first charge plus the second charge, and the total calcium concentration passes a threshold, then the trap closes. If it doesn't pass this threshold, it remains open. So where does the short-term memory come in? Well, after the first depolarization, you get an increase in charge, which rather quickly dissipates over time. If it has dropped enough, which is after 20 seconds, so that when the second charge comes, we don't reach the threshold, then you don't have the response. You don't have the memory. The short-term memory is in if there is enough charge in order to let the second depolarization reach the threshold. If the two charges within 20 seconds, you pass the threshold. After 20 seconds, you don't pass the threshold, the plant has lost the information. This model was reinforced by experiments that were carried out in the laboratory of Alexander Volkov around 2008. And in his experiments, rather than manually stimulating the hairs, he stimulated the trap directly with an electric shock, with electrodes. If he gave one large electric shock, which went over a particular threshold, then he could get it to close. If he gave one small shock, the trap wouldn't close. But if he gave many small shocks, eventually the trap would close. And it was always the question of whether the total electric potential went over a threshold. It could be one large one or several small ones, and in the end, it would close. So we can see here sort of a type of flow chart for a plant to decide, for the Venus flytrap to decide whether to close. We start with an open trap. The trap now waits for a stimulation. It's waiting for the mechanical stimulation by the prey. After the first stimulation, the first hair is touched, you're getting a receptor potential. The receptor potential is leading to an action potential. And then this leads to the beginning of the electrical memory, which is stored as an electrical charge. Now this charge starts going down. Now we go to the right here of the chart, and you're getting the second stimulation. The second stimulation of the hair causes the exact same thing. You're getting an action potential, which adds to the electrical memory. If this electrical memory now has passed the threshold, then you're getting the electrical memory through the electrical signal throughout the entire trap. This will cause a number of processes which will enable the trap eventually to close. If the second stimulation occurred late, after 20 seconds, the electrical memory threshold was not reached, and then the trap will remain open. So what we've seen here is a clear electrical mechanism which allows plants to have short-term memory. And again, I know this is a little bit hand-waving, but our brain also works through electrical potentials, and that's one of the mechanisms that's involved also in human short-term memory.